Welcome back to my channel, Form 4 Physics, topic Heat, lesson 14. The second question for structure. Omar boils water using an electric kettle of power 2400 watt. Meanwhile, Nazri boils water using an immersion heater of power 350 watt. So we have two persons using heating of two different power. If Omar and Nazri turning on the heater at the same time, their starting time is the same, whose water will boil first if they have the same mass of water of 1 kg. Here, they are using different power. They are starting at the same time. They have the same mass of water. Whose water will boil first? Now, whose water will boil first is referring to time. Which one will boil first, meaning which one will have a smaller time. So as usual, we collect the information. Omar using power 2400 watt. Nazri is using a power of 350 watt. Turn on water, turn on the heater at the same time. Whose water boil first? As I said, boil first referring to time. Whose water need a smaller time? Now both have the same mass of water. Their initial temperature is same. And of course both using the same liquid water. So it has the same boiling point. Okay. So since they are using the same mass, same initial temperature, both will have the same boiling point, which is 100, which means if you look at this formula, Q equals to MC theta. Okay, for both Omar and Nazri, they are using the same mass of water. They have the same specific heat capacity of water. Since they are starting with the same initial temperature and the final temperature is the boiling point same, so theta change in temperature also same. Therefore, the heat used is the same. Okay. So if you look here, Q equals to MC theta. But that heat energy is supplied by the electrical energy, which is power multiplied by time. You see the factor time is coming. So we are going to use the formula Q equals to PT. This formula actually was from topic 2. Power is energy divided by time. Therefore, the energy is power multiplied by time. In this question, the energy is the heat energy. So from the formula Q equals to PT, I make the P subject, the T, I bring it over. If you remember, I said in physics, from formula we can get the factors. So up and down is inverse. So to have a smaller time, we need a bigger power. Up and down inverse, A smaller time, a bigger power. So it must be Omar because he had power 2400. So Omar's water will boil first. So that was part A. Now we look at part B. We look at part B. By using calculation, prove your answer in A. What was our answer in A? The time that Omar used was smaller if the initial temperature of both water is 24. And of course, we are given the specific heat capacity of water, 4200 joule per kg per degree Celsius. They are asking us to prove our answer in A by calculation. Again, as usual, we collect our information. Initial temperature 24. The C was 4200. Prove the answer. And what was the answer? That Omar's time was smaller. So we have to do for Omar and Nazri, yeah? We have to do for both. Q equals to MC theta, use it twice. And the heat energy supplied by the electrical energy. And electrical energy is power multiplied by time. Now all we have to do now is find the time for Omar and Nazri, that's all. The power substitute, mass, C, change in temperature was 100, boiling point, final temperature, minus the initial 24. So for Omar, I got the T 133 seconds. Repeating the same thing for Nazri, the power was 350, mass was still the same, the C is still the same, again change in temperature 100 minus 24, I get 912. There are other ways of doing this calculation by cancellation. Okay, so if you see the time of Omar 133, the time of Nazri 912, therefore Omar's time of 133 second, this is S, I'm sorry, second, smaller than Nazri's time of 912 second. So we have proven by calculation. We look at C. If Nazri wants to use the same period of time to boil water as Omar, we know that Omar's time was 133 seconds. Nazri took a longer time, 912. So if Nazri wants to use the same period of time to boil water as Omar, what is the mass of water needed to be removed from the container of Nazri? Sorry for that. This is a very good question. This is a very good question. Part C, we watch. For C, Nazri want to use the same time of Omar, which is 135 seconds, and Nazri's power was 350. The initial temperature was still 24, and the final temperature was 100 degrees Celsius. I forgot the degree Celsius, I'm sorry for that. Now the question, what are they asking? That is the most important thing. How much mass of water must be removed? The mass of water removed, of course, must be the initial mass of 1 kg minus the mass of water boiled. Now this mass of water boiled using the time of 135 seconds. So if Nazri wants to use the same time, 135, with a power of 350, how much is the mass of water boiled? Okay, it's very important. They're asking mass of the water removed. It must be the initial mass of water, which was 1 kg, minus the mass of water boiled for the time of 135, which was Omar's time. Okay? So now we need to find what is the mass of water boiled. So again, Q MC theta, the heat energies supplied by electrical energy, which was power multiplied by time. So PT is MC theta. You watch, Nazri's power is still 350. Now the time of Nazri, you want to use Omar's time of 13. That would be 13. That would be 133. Sorry, this should be 133. Not 135. This should be 133. My mistake. I'll do the correction right now. 133. Okay. And the mass of the water boiled. Mass of the water boiled. This is what we are looking for. The mass of the water boiled for this 133 second. Of course, the C is 4,200. And the final the change in temperature, the final temperature minus the initial temperature. So now we take 350 times 133. You hold on. 350 times 133. That would give us 550. So this is the wrong answer because I use 135. So it will be 46550. Okay, I multiply these two, and this was 100 minus 24 was 76. So I bring 4200 times 76 here to the other side, and our answer, it cannot be this because there was a mistake in the earlier part. So that would be, do this calculation, that is 46550 divide by 4200 times 76. That would give us 0.145 146 kg. Now this is the mass of the water boiled, so which means the mass need to be removed was the 1 kg minus the 0.146. Okay, 0.146, which will give us answer 1 minus 0.146. That would give us answer 0.854 kg. So this is the amount of water that must be removed, because for using the time of 133 seconds, the mass of water boiled is only this. Using the time of 133 seconds for Nazri, using power 350, only this much of water is boiled. But initially he had 1 kg. So that 1 kg minus how much boiled will give us how much water to be removed. Our answer is 0.854. I'm sorry for the mistake here. I supposed to be 133, I put 135, so I have to do the correction. Our next question, this is again another very good question regarding the car radiator, which I will do in the next lesson. Thank you.